Hi, this is a brief overview of our VAC-VW 2025 paper on interpreting face recognition templates using natural language descriptions. The central question here is simple. Can we look inside a face recognition model's highly entangled template space and describe, in words, which facial attributes are actually encoded there? The key motivations here are transparency and trustworthiness. Face recognition systems normally work with high-dimensional templates that are excellent for matching identities but hard to inspect. If those templates contain additional attribute information, such as demographic attributes or attributes unrelated to identity, we need a way to expose it in a form people can understand. This is an overview of our method clip-SMU. A face image is projected into a template space, while text captions for facial attributes are projected through the clip text encoder. The model then compares the two spaces with cosine similarity and returns a ranked list of attributes expressed as natural language. The paper evaluates both zero-shot and fine-tuned variants. In the fine-tuned setup, the face recognition encoders stay frozen so their template behavior is preserved. Only the clip text encoder adapts using a symmetric cross-entropy objective over image and text pairs. In order to validate the natural language interpretations, we also train conventional attribute classifiers on frozen face templates. One model predicts all 47 attributes jointly, and the binary setup trains one classifier per attribute. These classifiers are not the explanation methods, but they give us a strong numerical reference point. For our experiments, we use the VGG Face 2 image dataset with matte face attribute annotations. The face images are aligned using the MTCNN model, then filtered so the contrastive objective has unique image text pairs. This means that we randomly remove one image from pairs of images which share the same attribute vectors. After filtering, this study uses about 260,000 training images and 15,000 test images. The images are evaluated using ROC curves and AUC over the attribute accuracy. And here are a few more implementation details that matter. So the face recognition encoders are kept frozen and only the text encoder is adjusted for clip-SMU. The classifier baselines also use frozen backbones and train only the added prediction layers, with binary cross-entropy as the objective. The attribute prediction ROC and AUC results show three main patterns. First, fine-tuning usually improves clip-SMU, especially for many non-demographic attributes. Secondly, swing face templates preserve more attribute information than other face. Third, dedicated classifiers are still numerically stronger, so clip-SMU is best understood as an interpretable language layer as opposed to a general-purpose attribute classifier. The qualitative examples here make the trade-off easy to see. Pre-trained clip tends to output many attributes, including false positives. Clip-SMU other face is more conservative and misses more. Fine-tuned clip-SMU and the swing face variant land in between, producing useful but still imperfect language descriptions. To summarize, our main contribution is a practical way to move from an opaque biometric representation to language-level evidence. For ENFIELD, the broader value is auditability. This gives the researchers and other stakeholders a clearer way to ask what information a model keeps, what it discards, and how that depends on the architecture.